Okay, hello everyone. I would say that we start with some technical introductions to give the people more time to join the meeting. Hello everyone. Welcome to all of you joining today's webinar organized by COREu and PilotSTRATEGY project. It seems like the topic is of high interest. We received a lot of registrations, but I only see a few participants from the registration list. So I think we have the project introduction at the beginning, so maybe more people will join. Over the next hour, we will hear about site exploration, about storage potential, also reservoir simulation, and we will focus today on Czech Republic and Poland. We from COREu will cover the Czech Republic part, while PilotSTRATEGY will cover the Poland part. And before I hand over to Thiago and Isaline for the project introduction, just a few technical notes. Your microphones and cameras are muted for now, but please feel free to submit your questions already in the chat or in the Q&A box. We will address them by the end of the meeting, and then you will also be able to open your camera and microphone. And as you see, the webinar is also being recorded. So after this webinar, we will stop the recording. So during the Q&A, you can just talk without being recorded. Now I would directly like to hand over to my COREu colleague Thiago from SINTEF to give you some introductory words on COREu.
All right, hello everyone, good afternoon. My name is Thiago Silva. I am a research scientist at SINTEF, and in COREu, I'm leading a work package on the CO₂ routes. I want to share with you some slides such that you can very briefly at least follow what I'm talking, so I think it might be easier. All right, I hope you can see my slides, and I have only 5. So COREu is one of the largest ever funded EU projects on CCS, so which aims to develop these CO₂ routes across Europe and mature the CCS routes in different regions. So it's a project that is coordinated by SINTEF Energy Research in Norway and involves many partners. This is not the latest, but so it started in January 2024. So it's a 4-year project, and it is about 35 million euro, so 39.3 funded by the European Commission. It has 43 partners, so it's a very large project. We like to say it is a project of projects. So involves technology providers, gas transport operators, and research institutes, universities. And as I said before, the whole point is to demonstrate the key technologies involved in the CCS value chains, and also support the development and maturation and the risking of the CCS routes in Central Eastern Europe. So in general, there are 3 main pillars. So as I said before, demonstration is one of them, and there is a full demonstration in Greece and also a part in Norway. And we are also developing research and all the foundation for these value chains, going from safe and design of these value chains, operation, risk mitigation, and so on. And as I said before, there are also studies on how to support the development of these different CO₂ routes in terms of economic subsidies and so on. I just have one slide of the demonstration. Here is in a Prinos site in Greece, where we're going to have is a old offshore field, and we're going to have an injection happening there. And the transport is going to be done with some innovation of the project, these vessels called GVP, transport vessels. And there is also another innovation of the project, is leakage monitoring system developed by MacGregor. So those 2 are core innovation systems, innovations of the project. And also there is some de-risking tasks developed in Norway as well. So in this project, there are many routes being developed. So there are studies being done in Czech Republic, Poland, Ukraine, and also in Greece, taking from the demonstration that is happening there, but also exploring different potential for upscaling and to maturing the CCS routes there. And today, we're going to be focusing pretty much in one of the regional scenarios, as we call, one of the regions, which is in Czech Republic. And I think I'll stop here. This is probably an okay introduction. And I can, of course, answer any other questions along the way.
Thank you, Thiago. Then I would like to hand over to Isaline to talk about PilotSTRATEGY. You're muted, Isaline.
Thank you, sorry. So I'm Isaline Gravaud from BRGM, the French Geological Survey. I will give some word about the PilotSTRATEGY project. So I'm really happy for having this opportunity to have the this joint webinar with COREu project, because I think that our project will be very complementary, as you will see. This is the PilotSTRATEGY project is a short name for CO₂ geological storage pilots in strategic territories. This is also a European-funded project in the framework of the Horizon 2020 program. This is Research and Innovation Action Project. And we are studying 5 regions in Europe for CO₂ storage pilots. We are a consortium of 16 partners from 7 countries, and the project is coordinated by BRGM, as I said. It's a 5 years long project that started back in May 2021 and will finish in April next year. So as you can see, we are very close to the end of this amazing project. You can see the list of other partners involved in these studies, and we'll give some very short overview of the project, because we are doing so much. But the idea of this project is to support the development of CCS in Southern and Eastern Europe in particular. We are focusing on the storage part. We are aiming at providing detailed studies of saline aquifers. So we are really focusing on CO₂ storage in saline aquifers. And the objective is to propose some pilots for CO₂ storage across Europe. And we have a very broad approach of feasibility of these pilots, because we are looking at all parameters for storage, of course, geological parameters, technical, but also very important, we are looking at social aspects, legal and economical. We have different work packages, and one of them is really dedicated to social acceptance of CO₂, of these CO₂ storage pilots. At the end of the project, we are proposing pilot development concepts, so including the CO₂ storage in a broader framework, and especially for the pilots in Paris Basin, Lusitanian Basin, and Ebro Basin. We are also proposing some pre-investment studies. That's it from my presentation of the project, because if you are interested in the results of our studies, you can check out the project website, where we publish all the reports that are produced in other regions that are presenting. And I will so give the floor now to the project webinar organizers, and you will have very much more detailed presentation by my colleagues from Poland about the Upper Silesia region. Thank you.
Thank you very much, Isaline. So we're jumping now back from PilotSTRATEGY to COREu, and I would like to hand over now to the COREu project partners from MND for presenting on the work done in Czech Republic.
Hello everyone. My name is Karel Bříza. I work at MND Energy Division as a project manager, and I have 10 years of experience in oil and gas. And for the last 4 years, I have been focusing on renewable energy sources like a solar system, wind power, and currently on CCS sector. I am here with my colleague from Geological section, Milan Pagáč. He is a reservoir engineer and advisor with a higher skilled and in his field. And we are represented here, leader of COREu project in task regional scenario, and we are also representative here industry sector. I will share our presentation. I hope that you see it. And
Yes.
just briefly about the MND. MND Energy Division is based in Hodonín in South Moravia, and it is a member of MND Group, and which is a key player in oil and gas sector and also energy sector. And we are also very active in the carbon capture storage, especially storage part. And our main traditional activity is drilling, exploration, and oil and gas production. And we also building and operating two underground gas storage facilities. So, and from since 2021, we focused on renewable energy, battery system, and newly in hydrogen technology. Slide. Sorry. Don't know how to. Oh, okay, so now it's working. We will start now about the possibility of onshore CO2 storage in the Czech Republic. I think it's a very important regulatory framework. In the Czech Republic, CO2 storage is permitted under the Act number 85 2012 called on geologic storage CO2, which is very important for us compared to another country, for example, in the Latvia and in Lithuania, where CO2 storage is full ban. And for example, Slovenia, Ireland, Finland, and Estonia, the CO2 storage allowed only for research. And for example, Germany, storage CO2 storage in onshore is banned, and offshore is possible. And for example, our neighbor Austria, they are planning to apply the ban on geological CO2 storage. Yes, so it's very important to statement of our government and our law. So that's mean that we can continue in our activity to searching and analyze a new possibility to CO2 storage in the Czech Republic. According to Czech legislation, CO2 storage is divided by volume. Storage under the 100 kiloton per year is like research and testing. And as you can see, more than 100 kiloton per year, it's a commercial scale project, which must requirements a lot of permitting and documentation processing. At the moment, in the Czech Republic has not yet carried out pilot injection test or commercial CO2 storage project, but we have several theoretical and industrial activities which can help us to push this project in the future. About the possibility or geological storage potential in Czech Republic. Czech Republic does not have capacity to become a major European CO2 storage site for neighboring countries, but can play an important role in decarbonization for local emitters, and which is very important, and it can help us to combine the Czech CO2 decarbonization with combination with transport by pipeline or railway to the, for example, through the Germany for final storing in North Sea. According to CCUS Development Action Plan, which was improved in March 2025, the total estimated storage potential for CO2 in the Czech Republic is approximately 1.2 billion ton. And of this, 25% is attributed to saline aquifers. In the Czech Republic, we have three main regions or areas for CO2 storage. Very important or region with large potential is northwest of the Czech Republic. It is Limnik-Permo Carboniferous, but at this moment this area is not explored, and it needs another investment and exploration like a 3D seismic survey or new wells. Another very important region is South Moravia. It is geological structure Wine Basin, Vienna Basin, and the slope of Bohemia Massif, which is the most promising area for I think for the beginning of CO2 storage in the Czech Republic, and also for MND, because in this area we have 5 exploration license. We continue in historical activity in this region in oil and gas production. So this area is very for us not new, and we are searching and analyzing potential for CO2 storage. Last one for CO2 storage is North Moravia. It is geological structure Carpathian 4 deep, but there is a small storage structure with the limited capacity. So as I said, for us is South Moravia most important. On this slide, you can see that for CCS activity or for CO2 storage is very important to have strong theoretical preparation. So our key researcher partner in this area is Czech Geological Survey, with whom MND closely cooperates. And since 2003, the Czech Geological Survey has been involved in many theoretical projects as EU Geocapacity, TOGEOS, CO2 Stop, and ENOS, which focus on refining CO2 storage capacity, analyzing potential storage areas, and working together on the international CCS researcher. According MND activity, MND has also experience with the theoretical and industrial CCS project. We have participated in the several research and development projects such REP, CO2 Spicer, and currently COREu project. But for us, it's now very important, the key project for our future. It is CCS Moravia project. It's a full chain CCS project. We are cooperating on this project with cement plant Mokra, which is under the Heidelberg Materials Group. And just shortly about this project, we are expecting annual storage capacity around 800 kiloton. New design or the design of this project use 4 new injectors, 4 in the Palladian structure and 4 in the Devonian structure. and project lifetime of this project is 25 years. The range depth of the geological formation is 3,000 meters, and total storage capacity for this time is 23 million megaton. The project, of course, depends on European funding. We applied to this project to EU Innovation Fund 3 times. We get a very good evaluation, but we couldn't reach the financial. So we are waiting for the new possibility of the financial, and we are continuing the technical preparation. So it's a very important project for MND, and also key pilot project maybe for the Czech Republic. So that's all from my side, and now we'll continue my colleague.
Hello, everybody. As Karol mentioned, there was in the past, for example, REP CO₂ project. In the past, the CCS activities were focused especially on depleted oil and gas fields in the Czech Republic. This is one of them, and the duration was just 2 years and was supported from Norway grants. And the main project objective was to make a significant contribution to the development of geological CO₂ storage technology in the Czech Republic. Depleted oil and gas field with limited aquifer was selected for the evaluation. It was interesting that it was cross-border field. One part was in the Czech Republic, and another part was in Slovakia. And the reason of this, or objective of this project, was not to do real pilot CO₂ injection, but essential steps were taken toward the implementation of the pilot project for geological CO₂ storage. For example, geochemical, geomechanical tests were carried out within this project, static and dynamic modeling, also risk assessment, monitoring plan was built, and also the publicity and information dissemination was carried out to make public more familiar with CCS activity. That time it was 20 years ago, so 10 years ago. The first project where MND itself became really active was CO₂ Spicer. In the previous projects, MND just provided data available, especially production data, well data, and so on. But within CO₂ Spicer, we were active. We were active in building static model and dynamic model. And this project was also granted from Norway grants, and it duration was since November 2020 to April 2024. And the main project activities were preparation of a pilot CO₂ storage site in a naturally fractured carbonate reservoir. Another objective was to serve as a model example for potential implementation of additional CO₂ storage sites in the Czech Republic and across Europe. As I mentioned, we developed a 3D geological model and dynamic model of CO₂ injection. Geomechanical and geochemical properties and tests were carried out, and also the risk assessment associated with CO2 storage, and monitoring plan was prepared within the project for several scenarios of further development. Then, after these projects that were focused on depleted oil and gas fields, we realized in MND that the storage capacity is very limited in our fields. And so we tried to focus on saline aquifers, and that was the goal of COREu project. And we tried to find large enough aquifers which will provide the sufficient or interesting storage capacity. As in the Czech Republic, we are onshore, so those aquifers were onshore. And as Karel mentioned earlier, our storage potential is limited in the Czech Republic, suitable mainly for local industry, not for really big CO2 producers. Still, investments is needed for exploration, including 3D seismic survey, drilling operations, geological assessment, geochemical, geomechanical, reservoir simulation, monitoring preparation, because those aquifers are not good characterized. There are not too many wells and seismic available. Within COREu, we focused on Southern Moravia region. That's this one. MND is responsible for work in this region, and Northern Moravia region, which is here. And Czech Geological Survey, together with Unigeo, are focusing on this part of the Czech Republic or Moravia, which is part of the Czech Republic. Within the COREu, MND evaluated 2 aquifers, one in Vienna Basin section, and the second one in slopes of Bohemian Massif. And we built static model, dynamic model, and with the goal to estimate CO2 storage capacity. Czech Geological Survey and Unigeo evaluated three structures: Janovice Depression, Jablko, Graben, and Rosava structure. They built 3D static models, and the storage capacity was estimated by volumetric method, not by dynamic simulation. This is the example of MND work. This is from Vienna Basin aquifer. As I mentioned, we tried to find as large aquifer as possible. And this is the largest aquifer in Vienna Basin section in lab horizons. The dimensions are 30 by 10 kilometers, but reservoir thickness is quite limited. The reservoir rock is of very good quality, good permeability, good porosity. And what dictates the storage capacity here is the pore volume, and as well the possible level of overpressurizing. We use 20% because this is not depleted, so we have to overpressurize to store some CO2. But this needs real and proper geomechanical characterization, which is not done within the COREu, to set the possible level of overpressurizing. The second aquifer was from Bohemian slope massif. It's a basal Jurassic complex, an aquifer in Gresten sands, which is the lower part of the complex. These Gresten sandstones are of very good reservoir quality, We assume that this sense is connected with upper section Nikolčice beds, which is medium reservoir quality, and as well with Vranovice carbonates, which is heterogeneous fractured reservoir. The whole complex has size of 15 by 7 kilometers, and thickness is up to 900 meters of the whole complex. It is possible that in the northwestern part here, this complex might be connected with another aquifer. So this cross-section shows CO2 saturation after 3,000 years after termination of CO2 injection. CO2 was injected in the model during 25 years, and then another 3,000 years was added to simulate CO2 plume movement. As you can see, here is the injector, and the CO2 is by gravity migrating upwards through the structure. So as I mentioned, depleted hydrocarbon fields in the Czech Republic contain a lot of data, but and the reservoirs are very well characterized, but the CO2 storage capacity is very limited in our country. The biggest fields we have been converted to underground gas storages, so they are not available for CO2 storage. So we've currently focused mainly on deep saline aquifers, and they have a larger pore volume available for CO2 storage, but usually due to complex tectonics, they are closed, not opened, and isolated into small blocks. Another disadvantage is lack of data, so new seismic wells, logs, cores, testing, and modeling is required. On the other hand, a small number of legacy wells are in these aquifers, so which is let's say advantage, because legacy wells are usually source of risk for CO2 leakage, and additional expenditures for proper CO2 resistant abandonment are required. So that's all from my side.
I can just add it that thanks to COREu project, the Graston sandstone structure, which was analyzed, we are counting it, or we are preparing a conceptual study for small emitter, storing the CO2 in this structure. It is also local emitter from the glass industry, and annual injection we are thinking or design it around maximum 100 kilotons per year. So it is good for us to have this new structure, and we are continue in this in the CCS activity. So that's all from Czech side.
Thank you very much for your presentation. It was very interesting. I would like to hand over now to PilotSTRATEGY. And since we're a bit behind schedule, it's not a problem, but there were already some questions in the chat. So maybe Karel and Milan, if you have the time already during the presentation to see the chat, and maybe you can directly answer the questions. But apart from that, if we don't have the time after the end of the webinar to answer the questions, we can also follow up via email. So now, Thomas, the floor is yours.
Thank you. I'm sharing my screen.
We can see it. It works.
Okay, great. Good afternoon, everyone. My name is Tomasz Urych, and I work as a reservoir geologist in Central Mining Institute in Poland. And I would like to continue the description of the PilotSTRATEGY project, and now I will focus on the main achievements for the Upper Silesia region in Poland. And I would like to present the results of research on the geological conditions of selected locations, storage potential, and related challenges. During my presentation, I would like to begin by reviewing geographic situation of Upper Silesia coal basin and location of CO₂ emitters. Next, we will move on to the location and storage potential of Upper Silesia region. Third, we will focus on the research methods and tools used in tasks related to static and dynamic modeling. Following that, we will discuss the geocharacterization results obtained from the research in two selected areas. And other important points to mention include an assessment of the storage capacity by simulations and legal conditions for the use of CCUS technology in Poland. The region of Upper Silesia is located in the southern part of Poland and is characterized by very high emission of CO₂. The annual emission exceeds 33 megaton of CO₂. Although in the region there are over 100 CO₂ emitters, over 90% of emission come from approximately 15 large hard coal power plants and from coke and metallurgical complex. But in the last time we observe increasing share of renewable energy sources. Let's talk about the location and storage potential of the region. There are two possible storage places have been identified in the region in deep saline aquifer. The first one is COREu reservoir located in the south part of the region and Łazice located in the north. The main purpose of our work in this project was enhancing the maturity and confidence level of CO₂ storage resources by studying new data, reprocessing current data, and conducting new dynamic simulation studies. Now I will outline the framework of our methodology. Geocharacterization consists task connected with static modeling with uncertainties and task related to dynamic modeling. The first step of static modeling was construction of geological grid, then well lookup scaling, property modeling, and considering geological uncertainties. And if we talk about dynamic modeling, we focus on storage capacity optimization and observation of CO₂ fate on the long term. We used Petrel software with Eclipse simulator. Let's move on to the description of our first area with CO₂ storage potential. It's COREu deep saline aquifer. And in the previous our works in different research project, we analyzing the west side of these potential layers. But in this project, we focus on the assessment of possibility increasing the CO₂ storage potential in these layers. The Bovis layers are located in lower Miocene sandstones with the thickness of the Bovis layer is variable, usually between 50 and 250 meters. Average porosity is slightly higher than 10%, and average permeability is about 40 millidarcy. And the first step of construction of geological grid was fault modeling. We observed that faults occurs only in deep layers underlying the reservoir and doesn't continue in the layer of reservoir nor above the reservoir. And in the next step, we developed this static model, which includes the top and the base of the reservoir, the top of the seal, and other horizon in the overburden of potential reservoir for CO₂ storage. In this picture, we can see an example of realization of porosity distribution and shell content distribution. This petrophysical modeling was developed based on well data from 14 additional log files with porosity and shell content. We also modeling permeability in this region, and we found only a small area with dimension 9 kilometers per 13 kilometers with permeability from 10 to 80 millidarcy. So the final output from this static modeling was porosity, shell volume modeling, and permeability. Let me briefly recap what we have covered so far regarding our first potential area. In the previous research project, we estimated capacity is about 46 megaton of CO₂, and in our project we calculated additional static storage capacity with value about 14 megaton. So we can say that the total estimated capacity for CO₂ aquifer is about 60 megaton. Let's move on to the description of our second area with CO₂ storage potential. It's Łazice aquifer. In the initial our model, we prepare fold and fracture model for the area about 62 kilometer per 24 kilometers, but mainly because data availability from this region, we selected only a smaller one with dimension 10 kilometers per 19 kilometers. And we start to preparing property modeling. The thickness of reservoir layer in this place is about 50 meters. It's located in lower Jurassic and the lower middle Jurassic, with porosity from about 8% to 22%. Permeability from 16 to 1478 millidarcy. Such high value of permeability are observed in two wells, Pongów and Emilianów. In this picture, we can see example realization of porosity distribution in reservoir layer and with the overburden. And the output of this task are the following properties: a model of phases, model of porosity, and permeability. The next topic I'd like to address is a comprehensive uncertainty analysis of that potential layer. Firstly, we focus on risk analysis of modeling structural surfaces. In this task, we prepare 50 stochastic variants of base and top of layer. And in the next step, we estimated values of P10, P50, P90 percentiles of model of pore volume. We presented on the histogram, and in knowing that the values of these percentiles, thanks to knowing this value, it's possible to indicate the stochastic models, which are closest to low, mid, and high case of pore volume. And this is the result of modeling of this pessimistic, optimal, and optimistic model of pore volumes. And based on this model of pore volume, we prepare a stochastic realization of porosity and permeability closest to such percentiles of pore volume. And this three variants of static model, then we use for different scenarios of dynamic modeling of this layer. In the next step, we assume free location of possible pilot scale injection wells. We assume injection rate about 300 kiloton per year, and injection time was 10 years. And we observed changes of pressure during the injection, changes of distribution of free CO₂, saturation, and distribution of CO₂ dissolved in reservoir water during the injection process. The next step was analyzes the best location of injection well, and the maximum values of flow rates was observed for the injection number 1 with amounts 1.22 megaton per year, which give the maximal potential CO₂ storage capacity about 31 megaton within 25 years. We assume maximum overpressure in the top of the reservoir layer, 20%. In the next step, we assessment what degree of individual uncertainty elements affect on the CO₂ amount possible to be injected, and we analyze 8 parameters affecting volumetric values. Moreover, we analyzed what part of injected CO₂ is dissolved in reservoir layer, dissolved in the water, and what part injected CO₂ is still in free gas after 25 years. As we know, CO₂ injected in porous media can be trapped by 4 different trapping mechanisms, and structural stratigraphic trapping, residual and solubility trapping were analyzed in Petrel software, but mineral trapping was analyzed in PetroAsim software. And in this case, we analyzed we observe model during 1,000 years after they stopped the injection, and we observed that for example, coefficient of dissolution of CO₂ was between 11 to 13%, depending on the different scenarios of static model. And in the next step, we convert a grid from Petrel to PetroAsim software in order to mineral trapping. In this software, we were analyzing the amount of total CO₂ sequestered in minerals, and we were quantifying the CO₂ plumb migration and behavior on the injection and post-injection periods during 1,000 years. And we observed that the maximum value of the total CO₂ sequestered in minerals is approximately 63 kilogram per cubic meters. And based on the simulation results, it was determined that some minerals dissolved and some minerals precipitated. Let me briefly recap what we have covered so far regarding 2 potential areas. As I mentioned earlier, it was 60 megaton for Skoczów aquifer, and we found one selected injection well with the maximum capacity about 31 megaton. Finally, we will shift our focus to the legal framework of CCUS technology. All we know that CCS directive of European Parliament applies to the geological storage of CO₂ in the territory of the European Union member state. And the directive was implemented to Polish geological and mining law in 2030 with amendment in 2023. And according to Annex to Geological and Mining Law, which was created 11 years ago, geological CO₂ storage is allowed in Poland only on the offshore area in Baltic Sea. But work is underway on the so-called location regulation. And this is a draft amendment to the regulation on areas where underground CO₂ storage complexes are permitted. And the new version of this document will allow the creation of CO₂ storage sites in other locations, mainly onshore. And in the last slide, what is worth mentioning, the proposed amendment to the regulation is a response to the growing interest in CCUS in Poland, but also as a continuation of the 2023 amendments to geological and mining law. As we know, this document is currently being agreed with the ministry, but storage is still limited to the Cambrian reservoir in the area of Baltic Sea, which significantly limits the development of CCUS technology in Poland. But so-called location regulation is expected to be published by the end of this year. Thank you for listening. And last slide with acknowledgement. Thank you.